All right, so we're going to start to look at a more full version of vertex form. Here's that vertex form that we put in our vocab video. F of x equals a times x minus h squared plus k. So we're going to not worry about the a value yet being something other than 1, but when you have the h and the k in the same equation, we're just going to practice that for a minute and then we'll look at different a values. So we have f of x. We're just going to fill in some numbers and practice our graphing. So let's say we have x minus 1 squared minus 3. So it looks kind of weird writing it in that way, but what that means is if you have an x minus 1 in the parentheses, tricky x, you're going to shift to the right one, and then that minus 3 on the end means we're going to go down 3 units. So that is going to move your vertex from 0, 0 to the right one down 3 is the ordered pair 1, negative 3. Our a value is still 1, right in front of the parentheses is where we would find if that number changed at all, which just means that our graphing pattern is still 1, 3, 5. Our axis of symmetry is going to be x equals 1, whatever the h or the x coordinate is of your vertex. So let's go ahead and graph that. If we were at the origin, we're going to shift to the right one down 3. Our new parabola, the vertex, is going to be right here, 1, negative 3. And we can do our 1, 3, 5 pattern. So up 1 to the right one, up 3 to the right one, up 5 to the right one. Let's get the points reflected on the other side of our axis of symmetry. We'll draw that in. And then let's go ahead and label which one is this. This is f of x. And then we'll just practice another one. So again, we're just doing a little practicing here. G of x. So let's say g of x was x minus 1 squared and a plus 2 on the end. So the translation's happening if you have the x minus 1. Tricky x, you're going to go to the right one again. And then that plus 2 means you're going to go up 2. So your vertex shifted to positive 1, positive 2 if you're going to the right one and up 2. Our a value is still 1, which gives us a 1, 3, 5 graphing pattern. And our axis of symmetry is x equals 1. So we're going to go from the origin to the right one up 2, plot that point. Now do your 1, 3, 5 pattern. And here is our, which function is this? This is g of x. If you notice, we said both of those had an axis of symmetry of x equals 1. If I draw that vertical line x equals 1, you can see that it does go through the vertex. It is the symmetry line cutting both parabolas in half. All right, h of x, let's throw in some different numbers here. Let's say we have x, I'm going to change that to a plus, so x plus 2 squared minus 1. By the way, how important is this squared right there? It's easy to forget if you guys are writing your own function. That's what makes this a parabola. That's what makes it quadratic, is that degree. It's a second degree function. So we want to make sure we don't forget that these functions all have a squared in them. All right, so our translations, if we have x plus 2, that means we would shift opposite tricky, so to the left 2. That minus 1 on the end, we're going to go down 1. So our vertex is going to be at negative 2, negative 1. Our a value is still 1, giving us a 1, 3, 5 pattern for graphing. Axis of symmetry. Oh, I did not leave myself a lot of space for part B here. Kind of crowding my graph is going to be x equals negative 2. So let's graph that. Our vertex is negative 2, negative 1. Graphing pattern, up 1 to the right one, up 3 to the right one, up 5 to the right one. I can kind of get that 1 unit off the graph. We will draw this in and label this was our h of x. So that's what parabolas look like when they have the horizontal and the vertical translation, is your vertex just gets shifted to a new point. And this h and the k will help us determine what that point is for the vertex. All right, moving on to our part B. How does the value of a affect the graph? Well, we know that the value of a will change our graphing pattern. It will tell us if we're opening up or down. It will tell us if we have a stretch or a compression. Does our graph get narrower with a stretch, wider with a compression? So I'll just make up a function for us to just practice real quick. Let's say f of x equals 2 parentheses x minus 1 squared minus 4. So first we would identify the vertex. So the vertex, it was at the origin, but it's shifted. X minus 1, so it's going to the right 1. This minus 4 tells us it's going down 4. So I can just go ahead and write the vertex as positive 1, negative 4. Our axis of symmetry is going to go through that vertex. So I know it's going to be x equals 1. And now let's talk about that a value. Our a is equal to 2. So it's a positive 2. This parabola is opening up. And the graphing pattern, we take that 2, multiply it by 1, 3, 5. So we're going to have a 2, 6, 10 pattern. If it helps, throw those over 1, and then we can graph our function. The vertex is 1, negative 4. And now we're going to do our 2, 6, 10 pattern. So up 2 to the right 1, up 6 to the right 1, and then up 10 to the right 1 is off the graph, so we can't fit that one on. Then let's get the same points on the other side. We'll go ahead and draw this in. So what do you guys think? Did this one have a stretch or a compression? Did this graph get narrower or wider? You can go ahead and sketch in that axis of symmetry too, right there at x equals 1. So because our a value was bigger than 1, this one had a vertical stretch. I'm just going to put vertical stretch, which means that our parabola got narrower. All right, let's wrap up this video. Last question. How does the graph of f of x equals negative 3 times x minus 5 squared plus 7 compare to the graph of the parent function? Well, the vertex shifted. We have a vertex in a new spot, so the new vertex is going to be x minus 5, so it's going to go to the right 5, so positive 5. That plus 7 on the end is going to move the vertex up 7 units, so the vertex is now at 5, 7. Because a equals negative 3, what does that tell us? Well, this parabola is going to open down. It will have a vertical stretch. Now, if you have to figure out if it has a stretch or compression, you take the absolute value of your a. So think about a positive 3. Any a value or the absolute value of a that's bigger than 1 stretches. It's going to narrow your graph. If it's between 0 and 1, it's going to compress it or widen the graph. So vertical stretch, which means narrow, it's going to be narrower. And then it's also going to change our graphing pattern. We'll take that negative 3 times 135. We're going to have a negative 3, negative 9, negative 15 graphing pattern. That's how it would be different than the parent function.